Hey, Mr. Harrodham here. Today we're going to go over some more reaction stoichiometry.
I think there's just been a slight misunderstanding, and I want to cooperate in any way that I can.
That's good for you, Bill Murray. Still dedicating this video to Bill Murray here. Here's some more Bill Murray sound bits here.
Back off, man. I'm a scientist.
Yep, there you go. So here we go. During a synthesis reaction of barium nitride, how many moles of barium nitride can be produced from 37.98 grams of barium if it is reacted with excess nitrogen? So first thing we have to do here is write a reaction here. So we know barium nitride has Ba and N because we know that this is a binary compound. Very important we write the formulas right though. We know that this is 2 plus for barium because it's in group 2. And we know nitride is 3 minus. So this is supposed to be Ba3N2. We are doing a synthesis reaction here. So we know that we can synthesize barium nitride from the elements of barium and nitrogen. We remember that nitrogen is a diatomic element. And we balance this reaction with a big 3 right there. This is a solid, this is a gas, and this will be a solid since we are doing a synthesis reaction. Okay, so here we go. I'm going to teach you how to do this with the checklist here. Remember, the checklist is step 1. Go to moles. Step 2. Mole ratio. Step 3. Go away from moles. Okay? That is the checklist. If you're talking Mr. Harrodham language here, we are doing tape, reaction, tape, until we get to the final answer. Okay? So, let's look at this problem here. We are starting off with 37.89 grams of barium. Okay? We are not at moles. Okay? We also need to focus on where we are trying to find here. We are trying to find moles of barium nitride, correct? When we eventually get done. Okay? So step 1 is to go to moles here. So you have to put grams on the top, grams on the top, grams on the bottom. What are we going to go to? Moles. This is barium and this is barium. And then we're going to do a swish like that, right? I'll put in my numbers in a second. Step 2, mole ratio. Moles on the top, moles on the bottom. What are we going to convert to? Moles. That don't make sense. That's why we got to use the substances. This is moles of barium here. This is moles of barium nitride here. Swish, swish. Okay, so then step 3 is to go away from moles. But here's the thing. We're trying to go to moles of barium nitrate, and we have moles of barium nitrate on the top here. Correct? So we do not need a step 3 for this problem. This is only a 2-step problem. Okay? So, step 1, use the tape. Here we go. The tape says 1 mole. We put 1 mole. It says the molar mass in grams. You have to look up the molar mass of barium on the periodic table. That would be 137.33 g-moles. Down with the gangsters. And then last step here is we do our mole to mole ratio here. So we have to do our infamous wham 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 whams. Wham 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 3. Wham 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 1. multiply, divide, you get an answer. Since this number has 4 sig figs, we are going to round to 4 sig figs. This is 0, which is not significant. 9197 moles of barium nitrate. See, that problem was not bad. But here's the thing, we're getting to the next problem here, right? And this is what I would call like the ultimate problem. Because that's what I do here, you know. Because
I'm going to ask you a couple of standard questions, okay?
these are just standard questions, yes. Okay, so here we go. Let's see if we can do this one. You can try it on your own and see if you can do it. How many grams of zinc phosphate will Siggy produce from a reaction of 45.7 grams of ammonium phosphate? So we have ammonium phosphate with excess zinc chloride, and we are going to make some zinc phosphate. So we're starting off with ammonium phosphate here. Ammonium is NH4. Phosphate is PO4. Ammonium is 1 plus. Phosphate is minus 3. So this is NH4, 3 PO4. Zinc chloride. Zinc is Zn. Chloride is Cl. Zinc is plus 2. Chloride is minus 1. So this is ZnCl2. Okay. These are double compounds here, so we are going to do a double replacement. So we make zinc phosphate. So we have ZnPO4. Zinc is 2 plus, phosphate is 3 minus. So that is Zn3PO4 2. So we have taken care of this and this. That means that ammonium ends up with chlorine because this does like a flow thing. So these are the inners that go together and the outers go together, right? So we have NH4 and Cl. This is plus 1 and this is minus 1. So that is the correct reaction. Then you have to balance the reaction, of course, here. I'm going to start with the phosphates here because there are 2 phosphates here. So I am going to put a 2 right there. 2 times 3 is 6 ammoniums. So I need 6 ammonium chlorides. But that gives me 6 chlorines and I have 2 chlorines. So I need a 3 here for my zinc chloride. Right? And 3 zincs and 3 zincs. Okay. Double replacement reaction here. We got to put in the state symbols too here. Rule number 2, all ammonium compounds are soluble. So I know that this one's an AQ. And I know that one is an AQ. Remember, you will get a list of the rules for your test and quiz. Zinc chloride. Chlorides are soluble except for silver, lead 2, and mercury. So this is AQ. There is no phosphate rule on the solubility rules. So this is a solid. Okay. Just so you know. Okay. So here we go. Now we have to do the ultimate problem here. We're going to do this with the checklist again. So step 1. Go to moles with the tape. Step 2. Mole ratio. And I wrote reaction. Awesome. Mole ratio with the reaction. Step 3. Go away from moles. Why am I writing moles big? Don't know. That is the tape again. Okay. So when you're using the checklist, it's very important that you figure out where you're starting and where you're finishing. Okay? So you don't do too many steps. Okay. So we are starting off with 45.7 grams of ammonium phosphate. Okay? We are trying to find grams of zinc phosphate. So we're going to eventually end up with grams of zinc phosphate. Okay. So we are going to need 3 steps to do this problem. Okay. Step 1, go to moles. So you have to do grams on the top, grams on the bottom. What are you going to convert to? Moles. This is NH4 3PO4. This is NH4 3PO4 because those are the substances that are the same for the tape steps. Then you have to do the next step. The next step, which is the reaction. Then you go swish like this, right? Moles on the top, moles on the bottom. What are you going to convert to? Moles. Okay. That don't make sense, so we got to look at the substances. Ammonium phosphate here. Because we have to go swish here. We're trying to get to zinc phosphate, so zinc phosphate goes on the top. That's step 2. That's not grams. It is not grams, Mr. Harridan. Very sad. I know. So you need a step 3. Moles on the top, moles on the bottom. What are you going to convert to? Grams. These are zinc phosphates, because that's where we're trying to end up. Okay. And that would be a swish there. And then we get equals, and then we get our answer. Okay. Step 1. Look at the tape. Tape says 1 mole. So we put in 1 mole here. Grams, we need the molar mass of ammonium phosphate. Do I need to show you how to get the molar mass of ammonium phosphate? No. 149.32. Because you know I would do, yeah. Yeah. Step 2. Mole to mole ratio, wham, 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 wham. Let's see, where's my ammonium phosphate? Wham, 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 wham. 2. Wham, 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 wham. 1. Final step, back to the tape. Tape says 1 mole. Put 1 mole. Zinc phosphate says we need the molar mass. Do you trust me with the molar mass? I think I have it memorized. It's 386.11. Okay. You would know how to find that, right? Of course you will. Okay. And then we solve the problem here by multiplying, dividing, multiplying, dividing, multiplying, dividing. Rounding to 3 sig figs. And we end up with 59.2 grams of zinc phosphate. That is our final answer on that problem. Okay? You guys are champions. The legend is